Hi, welcome to this Rhino and Panelingtools demo. I thought I'd kind of do a fresh demonstration this time because I wanted it to also incorporate the flow along command. So in this view here you can see some stuff that's kind of on the ground. We've got a couple of 2D Panelingtools examples, and over in the background there 3D paneling, and all of these have been told to wrap around a cylinder, and then we can split the surface and extrude and create these kind of 3D forms. So it's quite a playful kind of demo, a bit more architectural over here, but kind of playing with patterns and the likes initially. So what is Panelingtools? It's an add-on for Rhino and Grasshopper that is extremely creative. Once you get the idea, your imagination will take over. You'll want to try all sorts of things. I can't speak highly enough of it. I think it's extremely useful, especially for architects. It fits a huge need we have for kind of repeating and randomizing and morphing and doing all sorts of clever things with our facades. So this is how it basically works. You prepare a surface and then you create a grid on that surface. So we can see the red points here are, I would call them kind of the grid 1. There are a lot of 2D potentials with Panelingtools. So you can see here different patterns you can create using that grid. And you can also do custom shapes, and that's what we'll be doing. Generally though, people will tend to want to work with 3D objects. So what you do is you offset the red grid, and then we've got this blue grid that's spaced away, and that creates a zone. Okay, so every 4 red points there have got 4 blue points that go with them, and that creates a 3D zone that you can place objects into and do all sorts of clever things with them. So as you can see here, there's just 4 different shapes of objects, and they've been told to populate the grid spaces just randomly, so it's just allocated a random distribution to that. Okay, so here's some of the distribution methods that are available. Using these 6 different coloured panels, it's easier to understand what's happening with the distribution if you use just a coloured tile like this. So you can see here that where the curvature is minimal, Gaussian means kind of positive and negative curvature. So we've got positive curvature here, and we've got kind of negative curvature there. So that's where the distribution is working. Okay, another one based on curvature, kind of the mean curvature. This one, point attractors and curve attractors are the most commonly used ones. So you decide a position that's going to concentrate a certain component. So you can see here kind of the darker blue panels are clustering around the point positions, and then it fades away to the furthest away component. Okay, it's just doing stuff that's quite difficult to kind of work out yourself. It's difficult to be kind of random, whereas computers are quite good at generating randomness. Okay, and then the curve attractor, the curve is basically kind of running across the surface, and it's attracting the darkest blue panels to the curve, and they fade away in the distance. Okay, vector, I think what's going on here is the angle in relation to the vector. So you can see the blue ones are in a kind of flatter area, which would be kind of perpendicular to the vector, whereas the white ones are kind of facing the end of the vector. And then you've got things like random, which is a bit more easy to understand, and you can use a picture to generate the distribution that's supposed to look like a rhinoceros, but doesn't look too hot. And this one, draft angle, this is another kind of curvature based one, but draft angle is here we're kind of looking at the flatter it is, the lower the draft angle, the further away from the distribution. Okay, one thing we did touch on in class was that if you rebuild a surface, then you get a better distribution of the points, and we just get a more even arrangement. Okay, so let's jump to Rhino and work through this with a start file instead. This is the kind of the finished version, so I'm just going to open the start file. Better go for the folder. There we go. Okay, so I've got a lot of notes in here, so people that aren't at the class, you've got a chance of kind of following this. So we're going to start with this one here, and that's where there's the most notes on this one, because it's kind of the first part of the exercise. Okay, so this is paneling from a grid using custom 2D variable. Okay, so we're going to make this shape go onto the grid, but we'll be able to tell it to rotate them. The further away the objects are from our attraction point, the rotation will be different. Okay, so here it's saying create a paneling grid using the surface domain number option. Spans 8, U spans 8, V spans 6. So the U direction for this surface is this way, the V direction is this way. So there's a command called dir in Rhino which lets you shows you which way the surface is facing. So you can see we've got arrows pointing to the left, to right, and arrows pointing upwards. Okay, so the U is going to the right and the V is going upwards. Okay, so that will determine the distribution of the points. Okay, so we go to the Panelingtools commands and create a paneling grid using surface domain number. Okay, this gives you the kind of most even kind of divisions with no kind of leftovers. Okay, so you have to very carefully watch what happens in the panel here. So click on the surface to divide and enter. Okay, our options here says U spans 8, V 6. So U spans 8, enter. V spans 6, enter. You can see the dots already repositioning. Okay, and what I'm trying to do here is trying to get generally a square appearance. So that when I place my square geometry into it, it's going to not be too distorted. Okay, press enter to accept. Okay, the shape here, the red, I better just explain where that came from. Okay, so let's just have a look at the 3D view. Okay, and you can see we've got these black cylinders. So if we unrolled that black cylinder, that would give us the red shape. Okay, it's very approximately, the length here is 3.14, so it's pi times the diameter of the cylinder, which is 100. So it's 3.1416, I think is the length there. So it's 314.16 millimeters long and 240 millimeters high. So that's the height we've got there. So it always kind of, when you roll them out, they always look a bit bigger than you'd expect, but it is quite a lot of surface area on a cylinder. Okay, so that's where the red rectangle is coming from. So let's go back to here. Okay, so we want to do the paneling now. I have noted the some little numbers here. These are the numbers of these points. So at the moment, when you create them, they're grouped. Okay, if I ungroup that, so we'll ungroup it just temporarily, and then if I click on that one point, you can see that it shows its reference. So that's row 0. So this one is row 1, row 2. Computers always start counting at 0. They don't start with number 1. Okay, if we go this way, if I just do that again, oh, it's not choosing it. Let's use details here. Oh, I can see it there. So we're still in row 0, but we're point number 1. Go to this one, still in row 0, but point number 2. Okay, these numbering is very important, because if we end up with different numbers of points between upper and lower grids, it fails. It won't work out. We have to maintain the same number of points with any offset grids. So I'll undo that to make sure we've still got a group. Good. Okay, so we're ready to actually make this object go onto the grid. So we go back to Paneling Tools, Paneling from the Grid, Custom 2D Variable. Okay, so it's asking me to pick the paneling grid, enter. Pick the base surface if it's visible, so it is, so I'm just going to pick it. Okay, and then we get the more serious options. Okay, so it shows you here the pattern method should be rotate. So pattern method, rotate. Distribution method, point attractors. So change the distribution method to point attractors. Okay, there isn't any other options I need to change here. Pulling curves is for when you want the geometry to kind of go back onto an object, so we don't need to do that. It's just going to sit loose, it'll be fine. Okay, so I press enter now to accept those options. Right, it's asking me to select the attractor points now. I've just got one. I've just got a blue point sitting here. Enter. And now it's saying select the unit pattern curve. So that means that's the object, the shape. So this is just a little tracing of an oak leaf. So that's my unit pattern curve. Enter. The bounding box of the pattern, of the unit pattern curve. So this is this green square here. So this keeps the leaf inside the cell. So click that, enter. Origin point, because this one's going to be based on rotation, it needs to know where it's rotating around. So click the point, and then this is where you often miss out on the point. Something here, minimum rotation 0. Okay, so what's going to happen here is that the maximum rotation will happen nearest the point. Okay, so I'm going to say minimum rotation 0, enter. Maximum rotation, let's go for 180. Enter, and there it goes. Okay, so you see the furthest away one, the furthest away from the attractor, has got the least rotation. Okay, so it's just doing it logically, and the ones nearest the attractor have got the most rotation, so they're nearly 180. And only if that point was right in the middle of one of these would it be actually 180. So they're nearly 180 in this area. Okay, so that's our first distribution, and what happens is it groups these, which is quite useful because we want to place this onto the object. So we need to look in 3D from the next bit. So if we go to the perspective view, okay, now there's a couple of notes here regarding flow along, so we can try and get these shapes onto that surface. Okay, so flow along note number 1, when it asks you for the base surface, what we want to do is pick roughly somewhere here. Okay, when it asks us for the target surface, we'll pick this darker line, because this is a seam. This is the seam of that extrusion. Okay, so let's do the flow along now. So it's a fantastic command, flow along. So it can be 2D shapes like this, or it can be 3D objects. So we've got flow along surface. Okay. Oh, I had the objects already selected, so let's just go from the start again. Flow along surface. Select the objects to flow along. Click the leaves. Enter. Base surface, select edge near a corner. Okay, so we zoom in and we pick just about there. Seems very loose, this. And then it's saying target surface, select an edge near the matching corner. So it doesn't have to be absolutely exact, it just has to be roughly the same place. Okay, and there's our leaves. Okay, so you can see that leaf is this one. That leaf, oh, other way around. Yeah, that leaf is this one. This leaf is that one. So it's wrapped them effectively, kind of starting again from here. So it's gone kind of round that way. Okay, so what you can do now is use the green to split the cylinder. So let's just show you that that's a 3D cylinder. Okay, and then if we get the split command, split the object to split is the cylinder, enter, and then pick the cutting edges, so click on the green and enter. So as we think about that, there's a lot of surfaces created there. So these are now deletable. These are small cutouts on the cylinder. So we can get rid of all those. If I just do a couple of deletes, I can get rid of those. Okay, and now we can make this more solid. If we offset SRF, select the surface, enter, it's showing you the direction it's going to go. I want it to go inwards. A distance of 3 is fine. Solid, yes. Both sides, no. Corners, sharp. Enter. There's a good thing about that. It's a heck of a lot of offsetting to be done there. Shouldn't crash, it should manage it. Maybe a bit brave that I'm in a shaded view, but there we go. Okay, there is an object here that can be deleted. So we've got the group of the leaf shapes. They're not needed now, they can be deleted. Okay, on my layers I've got a cylinder base and a top. Okay, the top needs extruded, but the base is solid already. So offset SRF, pick the top, flip it again, it's the same distance, so press enter, and then you could boolean those together. So solid tools, boolean union, pick one, whoops, let's try that again. I think there might be a couple of curves here that we don't need. Yeah, let's just get rid of that. Maybe here as well. Curve. Okay, boolean union. Pick 1, 2. Okay, let's just do it one at a time. Extrusion. Okay, I'm going to hold shift and grab the others. And enter. They should all go blue. There we go. There's our first panelled and flow along. Okay, so we could possibly do the next one from this direction. I think we can. Probably best not to be in the shaded view though, so we'll go back to wireframe. So most of these notes disappear now, but the next one, the pattern method is mean and the distribution curve attractors. Okay, so a mean distribution allows you to go from one shape to another. Okay, it's got to be two shapes, it can't be more than two. Okay, but we're going to transition from a star to a pentagon. Okay, so we need the grid first. So let's make the grid the current layer. Oh, it is already. So paneling tools, create a grid. We'll just use the same settings for the grid each time. Okay, select surface to divide. Good to go. Enter to stop. Okay, then paneling tools, paneling from grid, custom 2D variable again. Okay, the base surface is here. The pattern method is mean. The distribution method is curve attractors. Enter to accept those options. It's asking me to select the attractor curve. Enter. The start pattern is the star. Enter. Bounding box, the square. Enter. End pattern is the small pentagon. Enter. Bounding box has to be the same, otherwise the pentagon's going to get really big. There we go. So we've got the biggest stars clustered around the curve, and it fades away to the pentagon furthest away. So we're getting these kind of transition stars the further away we go. Now you have to be a wee bit careful if you're doing this one, so that you don't induce any kind of twist on the object. So the start point for the star shape was here, and the start point for the pentagon was directly below that. You know, if the start point was here, then you'd find that the star kind of twists sideways, and we can see that in the finished one. I'll show you it when we get there, back to there. Okay, so the flow along can be done now. So if I flow along SRF, so objects to flow along, stars, enter, position near this corner, position on the seam, and there's our stars. Looks funky. Okay, next we did the split. So we split the black shape, enter, with the white shapes. Looks quite messy there now. Probably best to switch off the base and the top so we don't lose them. Okay, and then I can delete the little surfaces we don't need. We've also got the original stars there, the group, that can go. Okay, so this is all part of one object now. And then we did extrude, sorry, no, we did offset SRF. Should be the same settings, but we do need to flip it. Enter. Shouldn't take as long to generate this because it's a simpler shape. Tops and bottoms. Another curve there we can get rid of. Offset this. Flip it in the way, and then Boolean. So 1, hold shift, enter. Looking good. Let's just do a quick shade, make sure things are going the way we want. Brilliant. So we come over to the 3D setup now. Right, probably best to keep this in 3D because it's a bit easier to see what's going on when you do the offset. If you're looking down on it, you can't tell the grid has been offset. So this is paneling from grid, custom 3D variable. Bit different number of spans in the U and the V direction, and then we're going to offset the grid by 3 units. Okay, so paneling tools, create a grid. We'll use the old surface domain number again. Okay, click on here, enter. So just doubling these numbers. Okay, so this is 16 and 12. Okay, so 16 in that direction, 12 in this direction, enter. Okay, next we want to offset the grid. So this one's a new one, paneling tools, grid utility, offset points. The distance wants to be 3, enter. Select the points, enter, and it needs to know which way this surface is facing, so it's asking me to pick the surface, and we see the points have gone upwards. That's what we want. So I don't want it to be too thick because the components aren't very thick. Okay, I'm going to put the offset grid onto the offset grid layer, just so it's a slightly different color. Okay, now this one's a bit trickier to set up. Okay, I just need to be able to see the grids and the objects. This is my module objects list. Okay, so this is my list is made up of 1, 2, 3, 4, 5 objects, and they get slightly more solid as they go from the first one to the last one. So if I just shade that, you can see the whole gets smaller and it drifts up to the top corner. Then we end up with a solid one. Okay, so you get quite an interesting kind of panelled facade type appearance from this. So back to 2D wireframe. Okay, so it's paneling tools, paneling from grid, panel custom 3D variable. Okay, first grid is the lower one, enter. Second grid, the upper one, enter. Okay, pattern method is list, so that's okay, it's remembered it from when I last tried this. And the distribution method is point attractors, and you can see there's 2 blue dots that I've left in place. So point attractors is correct as well. So enter. Attractor points 1, 2, enter. Okay, now this is where it gets a wee bit different. So there's no bounding boxes on these because they don't actually need one. They're all effectively the same shape. They're all extruded squares of the same height. So we don't need a bounding box on these particular objects. If they were getting smaller and you wanted them to appear smaller, then you need the bounding box. Okay, but for this one we're okay with this. So I'll do a bounding box example as well. Okay, so select module 1, enter, but then it's saying select the bounding space, or just press enter if you want to use the same object. So we just press enter again. Module 2, enter, enter again. Module 3, enter, enter again. Module 4, enter, enter again. Module 5, enter, enter again. Now if you didn't want any other, if you wanted there to be fewer solid panels, then we would just finish it at this point. So let's just do that. So we just press enter again twice. 1, 2. Okay, so do you see there's quite a lot of the biggest aperture? So let's just shade it so you can get a better idea. Okay, so you see there's a lot more of the biggest aperture. We could change this. We could change the balance by picking this object more times. So watch what happens. There'll be less perforations in the next time we do this. Okay, so let's just go back to 2D wireframe. Okay, so just run through that again. Paneling tools, from grid, custom 3D variable, grid 1, enter, grid 2, enter. The settings are the same, so just press enter again. Attraction points, 1, 2, enter. Okay, module 1, enter, enter. Module 2, enter, enter. 3, enter, enter. 4, enter, enter. 5, enter, enter. 6, enter, enter. 7, enter, enter. 8, enter, enter. I'll leave it at that, so I'll just press enter twice. And you see how different it is now? We've got a lot more of the solid panel and fewer of the perforated panels. So you can change the balance as much as you want by just picking and repicking. But it gives you a really interesting kind of distribution. Okay, so we put that now onto the flow along. Okay, there is one of the options that says group the objects, so it's very helpful that it does that. We haven't got hundreds of objects to worry about, just got a single one. Okay, so this is a 3D object going to go onto here, so it's going to stick out outwards. That's inevitable. Okay, because it's got its own thickness. We're not going to trim, we're not going to split and then offset in the way. Okay, these are going to go outside the object. Okay, but it's exactly the same command. Flow along SRF. These are the objects to flow, so just pick here, enter, find a point near the bottom corner, and then go near the seam, the slightly darker line, and there's our objects on there. Let's shade that, see what it looks like. Okay, if I can get control of the cylinder, let's just get the extrusion and put that onto the cylinder glass layer. Then we've got a wee bit of colour. It's a bit easier to see what's happening. So it's instantly kind of architectural. It looks quite cool. Okay, let's just go back to shaded, to unshaded I should say. Okay, what I've got here is just a curved surface instead, because I want to show you that the flow along actually gives you a kind of a better result. If you do your paneling separately and then flow along, you don't get kind of faceted components. So bear in mind we'll use the same components. So we need the grid first, create a grid. Notice this has been rebuilt, so we get a more even distribution of the panels. So create paneling grid, surface domain number, enter. That's fine. Enter to accept that. Okay, then we offset the grid, paneling tools, grid utility, offset points. Distance, that's the same as before, so that's fine. So we pick the points, enter, pick the surface so it knows which direction to go. Okay, we'll put the second grid onto the offset grid layer. Okay, as long as we can see these, we should be okay now. So paneling tools, paneling from grid, custom 3D variable. Actually, we don't even need to make it variable. We can just do panel custom 3D here. We'll just use the same method. Be easier than messing it up. So custom 3D variable. First grid, bit trickier to pick. So it's group 12. Second grid was easier to find there. Enter. Oh no. Start that again. First grid, I didn't press enter. Group 12, enter. Second grid, enter. I'm just going to pick a point of tractors myself. So select attractor points. You can just pick a point. That'll do. Enter. Okay, module 1, enter twice. 2, enter twice. 3, 4, 5, enter twice to finish. Okay, let's hide the surface. Okay, there's the command called hide, very useful. So instead of hiding a layer, so can you see it's very straight along the edges here. Okay, it hasn't twisted or morphed the components the way Flowalong has. Flowalong has curved every component, so it's the same components, but you can see this is much more faceted appearance, and that might be what you want. You know, to some people that kind of looks more like a building in a way than, you know, having all the components curved. So, you know, neither of these is wrong. They're just different approaches. Okay, I did mention we would do a slightly different version with different sized objects. So what we could do is, I'll just use a sphere because it's a bit easier to see it happen with a sphere. So we need solid tools. Where's sphere? Where are you? I'm just going to type in sphere because I can't find the command. Okay, so let's use the grid snap here. It might help. So I'm just going to create a sphere. Okay, and then we'll put a bounding box around that sphere. Okay, so let's just create the box. On the standard, there we go, box corner to corner. Okay, and then the height we want to be 20 as well, so I think we're okay with that. Okay, let's just go back to 2D wireframe. Okay, so I'm going to try and put the cube now onto the sphere. So I want to move it down by half its height. Okay, and then it should be on the grid. That grid point there should be the same as that. So if I can move it from grid to here, so it's trapped the sphere inside. That's looking correct. Okay, so let's just copy this 3 times and we'll shrink the sphere inside each one. So I'll copy, try and get back to the grid point if I can. Should be there. Okay, let's go to the main grids and be a bit easier. Ortho off. Well, let's do 4. Okay, so it's the sphere that we're going to shrink, not the bounding box. Okay, so we'll scale. Okay, so let's make this 0.8. scale this one 0.6, scale this one 0.4. Okay, so we've got 4 different sizes of cubes. So let's delete that, delete the second grid because it's very low, and we'll just offset that again. Paneling tools, grid utility, offset points. Okay, select the base surface. It's just going to do it 3. Offset points, distance, let's make it 20 so it's the same height as the cube. Okay, select points, enter, surface or polysurface. Okay, so it should be the same height as the cube. So we've got a big zone now. So paneling tools, paneling from grid, custom 3D variable, first grid, enter, second grid, enter, list points, that's good, point attractor, let's just use 1, module 1, enter, but pick the cube this time, enter, module 2, enter, cube, enter, module 3, enter, cube, enter, module 4, enter, cube, enter, enter twice more, and this will push it a bit because we're using spheres. Here it comes. So quite a big ask to do this with spheres. Maybe should have chosen something a bit simpler, but it's much more obvious when you're using a sphere. And there we go. So let's have a look from the top. So do you see how the bounding box has kind of maintained the scale of the spheres? Shade it. Should look pretty interesting. Okay, so the bounding box has kept the spheres the size they should be. Okay, so what I'd like you to do for kind of next time we meet is create your own set of components so that we can put these onto our wavy roof. So in class I want you to ideally have these ready, but if you don't, have an idea of what you want to do, and then we'll create components, and if they need bounding boxes then do that. If they don't, then that's fine as well. Okay, so that's just a wee shade because that always looks good. Spheres always look kind of cool when they're shaded. So that's our little introduction to paneling tools. Hope that's kind of piqued your interest and maybe fueling a bit of imagination there. Cheers.